Hello there. We're going to get started on our first video lesson for the integral of transcendental functions. You should have the formula sheet with you while we go through these examples together. We're going to be focusing on these trigonometric integrals for this first lesson. Okay, let's get started with example 1. In example 1, we are finding the integral of 5x multiplied by the cosine of 2x squared. And we're taking the integral, of course, with respect to x. So if we take a look at our sheet here, I'm going to draw your attention to this second rule here. So the integral of cos u is sine u. So what we're going to do is take the argument of the function, or the angle, and call that u. So u here is 2x squared. If that's the case, what will du be? Du is the derivative of 2x squared. And so it is 4x dx. So now we're going to rewrite this integral using u right here in place of 2x squared. So we'll have cosine of u. The other thing we need to determine is how 5x dx compares with 4x dx. Well, 5x dx is 5/4 times 4x dx. And that means, therefore, that the 5x dx is actually 5/4 of du. So this means that we will rewrite this original integral like this. 5/4 times the cosine of u du. Okay, and again, how did we do that? We took the angle here and called it u. We found the derivative of u, and since that is 4x dx, and here we have 5x dx, when you divide 5x dx by 4x dx, you will get 5/4. So that's what we have, is 5/4 du. And now when we go to integrate, of course, this constant here can simply be brought forward like this. And now we have the integral of cosine u du. And on our integral page, we can see that that's equal to the sine of u. So now we have 5/4 times the sine of u. And of course, there will be a constant of integration. And finally now, in our final answer, we replace u with 2x squared. Okay, so we found the integral of the original function. It is 5/4 times the sine of 2x squared plus c. And of course, this means that if you take the derivative of this function, you will get this right here back, because the derivative and the integral are inverse functions. Okay, let's try the next one. It's very much the same thing. So we begin, we're going to take the argument of the cotangent function right here, which is also the angle, and call that u. So u is 8x cubed plus 3. Therefore, du is, the derivative of this is 24x squared plus 0 dx. Okay, so now again, we're going to rewrite this integral with a u right here. So we'll have cotangent u. Okay, but now here's when we compare 3x squared dx with 24x squared dx. So 3x squared divided by 24x squared is 3/24 or 1/8. Okay, so now we have the integral of 1/8 cotangent of u du. Okay, so again, right here we called this u, and the derivative is 24x squared dx. And instead we had 3x squared dx, so we had 1/8 of du. Again, in order to integrate this, we simply move that constant to the front, and then we can look up the integral of cotangent u on our integral sheet. It's here. The integral is the ln of the sine of u. So we end up with 1/8 times the ln of the sine of u plus c. Once again, in the final answer, remove u and put back 8x cubed plus 3. Okay, so that's the second example completed. Okay, let's try our next problem. So I would say these two questions are very, very much the same. We have one trigonometric function in each. Okay, let's try our next one. You can see the difference here right away. We have two trigonometric functions, one divided by another. So this really, since they have the same angle, this is really reminding me to pay attention to some trigonometric identities. And we have some written here on the page, okay? Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent, and tangent is sine over cosine. If you put these two things together, you'll find that since cotangent is the reciprocal of tangent, it is also therefore cos theta divided by sine theta. Okay, so that's actually how we're going to begin example 3. We're going to change the cotangent of 5x into cos 5x divided by sine 5x. So that is our new numerator. Underneath, in the original denominator, we still have cos 5x. Okay, so we replaced cotangent with cosine divided by sine. Now, what do you get when you take this fraction and divide it by cosine of 5x? Well, you'll be left with 1 over sine 5x. Okay, but that is also found here. 1 over sine 5x is cosecant 5x. So what we have is the integral of the cosecant of 5x with respect to x. Okay, maybe touch that up a bit with a little bit of this liquid paper. Oops, touch that up a lot. That's gonna take forever to dry. Okay, just ignore it. We'll move on. Okay, so we're going to take the integral of cosecant 5x. So The integral of cosecant is found here on our integral sheet. So we'll simply write this out. Our u, of course, is 5x. So when we write this out, we will have 5x here and 5x here. Okay, so let's try that to begin with. So we're going to have the ln of the cosecant of 5x minus the cotangent of 5x plus c. Okay, so all I did was follow along on the right hand side here, replacing u with 5x. Okay, now I should know also that I need to precede this with 1 over 5, since the derivative of 5x isn't 1, but rather 1/5. Now, if that's confusing for you, you can still do the whole thing where we say, well, u is 5x, and that means du is its derivative, which is 5 dx, okay? And then up in the original here, since we had only 1 dx, we take 1 dx, we divide it by 5 dx, and that's where the 1/5 comes from, okay? But since the derivative here is just a constant, we might be able to start skipping this and realizing that since the derivative of the argument is 5, we precede the answer with a factor of 1 over 5. Okay? Okay. Might get on a light here. It's getting a little dark. Okay, so let's continue now. And this is still wet. I'll fill in the C shortly, okay? I better not make any more mistakes. I actually ran out of my correction ribbon, so I need to get a new one. So here we go. The next problem that I wanted to go through is this one. We have sine multiplied by secant. The argument is the same for each. So here again, this is when we might use an identity. According to the identities listed here, secant is 1 over cosine. So I could start by changing this into sine times 1 over cosine. Okay, so in that step, of course, all I did was replace secant with 1 over cosine. But now we have sine multiplied by 1 over cosine, and that, of course, is the same as sine over cosine. And sine over cosine is tangent. So now we have 6 times the integral of the tangent of 1/2 t with respect to t. This is a definite integral, by the way. The first example that we're doing, that's a definite integral. Okay, so what we need to do is find the integral of tangent 1/2 t. Okay, so looking at our sheet, what's the integral of tangent u? It's the negative ln of the cosine of u. Okay, so we've got the 6. We're multiplying it by the negative ln of so we're taking the integral of tangent. Cosine of u, of course, u is 1/2 t. Okay, now we also need to make sure that out front we divide by 1/2. Why are we dividing by 1/2? Because the derivative of the angle is 1/2, just like in this previous one here. the angle was 5x, its derivative was 5, so we divided by 5. So here, the derivative of the angle is 1/2, so we need to make sure we divide by 1/2. So this will actually give me 12. Okay, making the final answer -12 times the ln of the cosine of 1/2 t. That's actually not the final answer because this is a definite integral. So I'm still going to have to substitute the upper and lower limits. Okay, now again, if that's confusing to you, you could add this in. U was 1/2 t, and that means du is the derivative of 1/2 times t, so it's 1/2 dt. Okay, and in this line we had 6 dt, right? So we take 6 dt and we divide it by 1/2 dt, and that gives us the 12. Okay. Okay, so now what I'm going to do is I'm going to leave that -12 out front, and then I'm going to substitute 1 and 0 where the t is. So we'll have -12, and then we're going to have the ln of the cosine of 1/2 times 1, which is just 1/2, okay, minus the ln of the cosine of 1/2 times 0, and of course that's just 0. All right, and now I just want to use my calculator effectively to come up with the final answer. Okay, so I'm going to show you how I'll do this, okay? So I've got the calculator in radians, which you definitely need to do here, okay? Keep your calculator in radians, and I'm going to, let me put that up again because I got a bit of a shadow. I'm going to punch in this part first, and then when I'm done, I'll multiply by -12. Okay, so I'm going to just do this. So I'm going to type in the ln of the cosine of 0.5. You probably don't need a bracket here. Ln of the cosine of 0.5 minus the ln of the cosine of 0. Okay, so I'm going to push equals. And then that has to be multiplied still by -12. So multiply by -12. And that's my answer right there. And I'm just going to round to 3 significant digits. So it's 1.57. Okay. Now, I realize that as I'm going through these questions that they are not easy. This is not an easy topic. And in particular, you haven't done any integration for quite some time. So you're going to have to work rather hard at this, but be patient with yourself as well, because it might not come right away, because as I say, you will have forgotten quite a bit about integration, I think, since your last math course. Okay, but please be willing to work hard at this. Okay, let's continue. This is the next problem I'm going to do. We have 1 minus the cotangent squared of x in the numerator. In the denominator, just this single term, cos squared x. So when there's only one term in the denominator, it would suggest that we should split this into 2 fractions. So in the first fraction, we're going to have 1 over the cosine squared of x. Okay, then we'll have a minus sign, and the second fraction will be cotangent squared x divided by cosine squared x. Okay, so each term in the numerator is divided by cosine squared x. Now we're going to use our identities work to simplify this and this. Well, 1 over cosine x is secant x. So that means 1 over cosine squared x is secant squared x. Minus, now what about this one? What is cotangent divided by cosine? Well, we just, in fact, figured this out in problem 3. Here was problem 3. This is dry enough to put a little C back. Maybe. Okay, so here's problem 3. Look here. We had cotangent over cosine, and then we did some work to figure out that that was the same as cosecant. Well, now we have cotangent squared over cosine squared, so that will simply be cosecant squared. Okay, so there's no point in going through all of the work again to show that cotangent divided by cosine is cosecant. You can simply refer to problem 3. All right, now in evaluating these integrals, we just look them up. What's the integral of secant squared? Write it down, and from it subtract the integral of cosecant squared. And you can see those here. All right, so we're gonna have tangent minus a negative cotangent. So we have tangent of x minus a negative cotangent of x. So tangent of x is the integral of secant squared x, and negative cotangent x is the integral of cosecant squared x. Okay, this will be plus c. The arguments have a derivative of 1. Okay, so there is no factor out front except for 1, and in the final answer, of course, we would change this to addition. Okay, we're going to continue. Let's look at problem 6. There's just one trigonometric function. It's here in the denominator. Notice its argument is the exponential function. Okay, but we have one trigonometric function. And it's in the denominator. Secant is in the denominator. So this is the same as if we had this, right? So we have 2 e to the x, and then it's times 1 over secant of e to the x. So hopefully you can see that this is the same as this, right? And 1 over secant, what would that be? Well, since 1 over cosine is secant, that means 1 over secant is cosine. So right here, this is the same as cosine of e to the x. So I'm going to do that in the next step. Okay, so 1 over secant of e to the x is the same as the cosine of e to the x. Okay, and now I'm going to use a u substitution. So just like we did with some of those first examples, we let the argument or the angle here be our u. So u is e to the x. What's the derivative of e to the x? Well, you might remember that the derivative of e to the x is e to the x. So we have e to the x dx as our du. Okay, if you don't remember that, it's here basically, right? This says the integral of e to the u is e to the u. Remember, if you want the derivative, you're going to read these backwards. So what's the derivative of e to the u? Read it this way. The derivative of e to the u is e to the u. Okay, so all of these can be read backwards. If I said to you, what's the derivative of tangent u? You would say it is secant squared u, and so on. Okay, so we're gonna rewrite this now, making this cosine of u, right? Cosine of u. Now we have 2e to the x dx, not e to the x dx. We have 2e to the x dx. So that means we have 2 times du. So this is 2 cos u du. Okay, so this is cos u, and 2e to the x dx, all of that is 2 times du, 2 times du. All right, so the 2 can come in front. We use the table to write the integral of cosine u. The integral of cosine u is sine u. So this becomes 2 sine u plus c. But we cannot put these values in for u, remember, because these numbers are x values. So the first thing we do is change u back to e to the x, right? Like this. And now into here we substitute first 1 and then 0, like this. You can leave the 2 out front, and then you go sine of e to the 1 minus the sine of e to the 0. So it's simply upper limit substituted minus the lower limit substituted. And now, again, a little bit of calculator gymnastics to get our answer. Okay, so could do it all completely in one step. Follow along in the display. So 2 bracket sine. Now to get e, we have to do shift ln. Sine of e to the 1, right? Minus the sine of e to the 0, bracket closed, equals. And there's our answer. Okay, and we would write down, we would round to 3 significant digits. So it's roughly negative 0.861. All right, so that is example 6. And I do intend to do 4 more examples with you as well. Okay, so this video might be fairly long. So let's continue. Number 7. Okay, so taking a look here, we have 5 tangent x multiplied by the ln of the cosine of x with respect to x. Oh boy. So remember, the key in solving these is correctly determining what you're going to call u. And so we have to think of the possibilities. Okay, so if you start by calling tangent of x your u, right, then you'd need to know what the derivative of tangent of x is. But to read the derivative of tangent of x, you look for it here and read it this way, right? So the derivative of tangent of x is secant squared of x. Okay, and that is not present in here. So that is how you know calling u tangent of x will not work. Okay, I guess another possibility might be calling cosine of x u, But if you did that, the derivative of cosine is just sine. That's not in here either. Okay, so I think that eventually you would realize that what you need to call u is this whole ln function. Make u the ln of the cosine of x. What would its derivative be? Well, let's find the ln of the cosine of x in the right-hand side. Here it is, okay? But it's preceded by a negative sign. So the derivative of the ln of the cosine of u is the negative of the tangent of u. So this is negative tangent of x dx. And that's good news because you do see a multiple of tangent x dx in here, right? So a multiple of tangent x is in here. And that's how you know this is the correct choice for u. So identify u, take its derivative, okay? So again, this isn't a derivative table, but it might as well be because the derivatives can be read right to left. So the derivative of negative ln of the cosine u is tangent u, which means the derivative of the positive ln of the cosine of u is negative tangent. Okay, just like that. So now what we can do is, this whole thing is now u, right? And this 5 tan x dx is negative 5 times du. It's negative 5 times this. So we have negative 5 times the integral of, this whole thing is u. Okay, so again, this whole thing we called u. 5 tan x dx is negative 5 times this, and therefore it's negative 5 du. Okay, now what's the integral of u with respect to u? And this one actually isn't on your formula page, but I mean, you can add it. It's the most basic rule that you learned in your last math course. When you're integrating u to the n, you do u to the n plus 1, and in front of it, 1 over n plus 1. Okay, and then plus c. So we have u to the 1 right here, see? So we're going to consider n to be 1. So we're going to end up with 1/2 u squared plus c here. So we have negative 5 times 1/2 u squared plus c, which is negative 5/2 of u squared plus c. And finally, don't leave u in your answer. Replace u with this. So we have the ln of the cosine of x, all squared like that. Okay, and that's perfect for a final answer. Just note that it would be the same as writing it this way. Ln squared of the cosine of x means the same thing. Okay, so that was problem 7. Here we go, number 8. Now, just like we saw here, this problem could be written this way. So it's the sine of x all squared. Okay, now we have to choose wisely what we're calling u. In this case, it's the function inside the bracket, the one with the outside exponent. So u, in this case, will be sine x. What is du then? It's the derivative of sine x. Well, sine x has a derivative of cos x. Okay, so now we're going to rewrite the integral. How are we going to do that? Well, this is u. So we have u squared to begin. And what do we do with the cos x dx? Well, cos x dx is exactly du. So we simply have this. Okay, so again, u squared. The entire cos x dx is our du. Use the integral of u to the n to make this 1/3 u cubed plus c, or 1/3, replace u with sine x. Okay, and now we evaluate between the given limits. So we can leave the 1/3 there, and then we're doing this. We're gonna have the sine of pi over 2 all cubed minus the sine of pi over 3 all cubed. And again, not easy to evaluate this with your calculator. So I'll show you what I would do. In this case, maybe I'll leave the multiplication by 1/3 to the end. So I'm just gonna work on putting this stuff in the calculator. So I'm gonna do sine of pi over 2. So I can do it like this, I think. Sine, and now I want pi over 2. So that's the sine of pi over 2. I want to cube the whole thing, so I'm gonna start over, okay? I'm gonna put that baby in a bracket, just to be sure. So I'm gonna do this, okay? Sine of pi over 2, like that. Cubed. That looks good. Minus, I'm gonna do another bracket. Sine of pi over 3. I want to cube that as well. Okay, push equals. Multiply by 1/3. 1/3. And there's the answer that I'm getting. Close to 0.117. Like that. All right. 2 more questions, okay? So bear with me for a couple more problems. Of course, you have the luxury of pausing these and resuming them when you're ready and so on. So feel free to take breaks as required. Question 9. Okay, so I have 5 cosine 2x in the numerator. The denominator is sine 2x to the power of 4. Okay, and as we just discussed, this would be the same as having sine of 2x in a bracket, just like that. Okay, now, remember in the last question we called the function that was in the bracket. So way back here, you remember? We said that sine x was u. And that's because it was in the bracket with the external exponent. And the same can be done here, right? It's inside the bracket with the external exponent, so it can be called our u. All right. So let's go ahead and state our intention then. So we're going to take u and let it be the sine of 2x. So then du is its derivative. So what's the derivative of sine of 2x? it's cosine of 2x times 2. Don't forget, you multiply by the derivative of the argument when you are taking the derivative. Okay, you divide by the derivative of the argument when you're integrating. So if I'm going to rewrite this now, okay, so the bottom is u to the 4, simply. Okay, so that part we've got taken care of. Now we compared what we have on top, so all the other stuff, in other words, within the integral, is compared with our du. So this is 5 cosine 2x dx. This is 2 cosine 2x dx. So take 5 cosine 2x dx, and you're dividing it by 2 cosine 2x dx. And what do you get? You get 5 halves. So we end up with 5 halves du. Okay? Now this looks weird, and that's because when we're integrating now with respect to u, we don't want this u to the 4 in the denominator. And so what we do at this point is bring it up. And you know what happens if it's u to the 4 in the denominator. When we bring it up, it's u to the negative 4. Like that. Okay? Now, the 5 halves essentially is our multiplier. And we use, once again, the integral of u to the n du, right? So we have u to the negative 4. So this will be a negative 3 and a negative 3. So it's 1 over negative 3 u to the negative 3 plus c. So overall, this is negative 5 over 6 u to the negative 3. Okay? U to the negative 3, however, is the same as sine 2x to the negative 3. And, of course, just to make things even more complicated, this is a definite integral. So we're going to be substituting 3 pi over 4 right here and pi over 4 right here. Okay, so we're going to have negative 5 over 6 outside of the bracket. And then I'm going to have 2 brackets, right? So it's going to look like that. Upper limit minus the lower limit. Okay, so in here should be sine of 2x, but x is 3 pi over 4. So we have to do 2 times 3 pi over 4 to get the correct angle. So what is 2 times 3 pi over 4? Well, it's the same as 6 pi over 4 or 3 pi over 2. Okay, same thing for this one. We take pi over 4, we're substituting it here, so it's sine of 2 times pi over 4. So that's the same as the sine of 2 pi over 4, which is the same as the sine of pi over 2. Okay, now, you might know these values, and if so, it will help, right? Do you remember what the sine wave looks like? You might remember that the sine wave starts at 0, goes up to 1, back to 0, down to negative 1, back to 0, right? At 3 pi over 2, it's at its minimum of negative 1. At pi over 2, the graph is at its maximum, rather, of 1. So now we have this. Okay, negative 1 to the exponent of -3, that just means 1 over -1. That's just -1, and this is -1. So we're going to get -2 in here. Okay, and that means the answer is 10 over 6 or 5/3. All right, if you need your calculator to actually evaluate these things, then, you know, just go ahead and do it. Like the sine of 3 pi over 2 can be done like this. The sine of 3 pi over 2. There it is, -1, you see? Same thing with the sine of pi over 2. But it would certainly be nice if you remembered the sine wave graph. All right, because we did study these now in second semester, I guess. Right, that's the sine wave. Right here is 90 degrees or pi over 2. That's 180. Right here at the minimum is 270 or 3 pi over 2. And right here is 2 pi or 360. Okay, one more example for today. And then you need to practice lots and lots and lots of these, okay? But here's our final example. I'm going to do this one as well. I'm going to begin by changing ln squared x to ln of x all squared, okay? So using some strategies that we employed, so we used that strategy here in number 9. We called the inside of the bracket our u, right? We did that in number 9, and not only in number 9, but also here in number 8, okay? So I think that strategy will work here as well. So let's see. If we call the ln of x our u, then we need to know the derivative of ln x and hope that it is present here. Okay, so the derivative of ln x, not its integral. So you have to find ln in the right-hand side, and it's here, okay? So ln u has a derivative equal to 1 over u du. Okay, so the integral of du over u is ln u, but the derivative of ln u is du over u. So the derivative of ln x is dx over x, right? So this is dx over x, which is the same as 1 over x times dx, right? So that's the same as this, if you like this better, 1 over x times dx. These are both exactly the same. And interestingly enough, we have that here, right? We have dx over x. So what does that mean? That means when we rewrite this integral, we can start with this part. This is u squared, and it's in the denominator. And then the dx over x portion is exactly equal to du. So now we have this. We simply have the integral of du over u squared. Now, how do we integrate this? Well, as we saw in our last example, we are required to bring this up. And so now what we're going to integrate is u to the negative 2. So we treat n as negative 2, and we write 1 over negative 1 u to the negative 1 plus c. So this is just negative 1, so we get negative u to the negative 1, but u is ln x. Okay, and that's fine for a final answer. Or another way to write that would be this, negative 1 over ln x plus c. Okay, and that is the last example that I was hoping to complete with you in this video. Please take the time to try all of the problems that I've assigned for you in Blackboard. Okay, thanks very much and have a good day.